Okay. So, last time we wrote some code. Let me hide this. Gosh. All right. So, last class we were working on our more generic version of our program. So, we're writing a Python program that has an initial value in some base. We've now expanded this to be a little bit more generic, where instead of it just only working for binary, which we wrote originally, we now wrote it to work for base 16. And since we support the entire alphabet now, it'll work for any base up to base 36. Um, we'll kind of fill in a couple of the gaps here today. What we did last time is we talked about a couple of uh, approaches to this. How many of you have ever seen the show or heard of the show MacGyver? Heard of MacGyver? The original or the remake? Didn't the remake last like half a season or, or something like that? Well, the idea with MacGyver is, every single episode he was stuck in some situation, and he only had whatever was laying around him at the point, at that point in time to solve some problem. And he was, he'd build an airplane out of like stuff that was like left over in a garage and that kind of crazy stuff. So, as computer programmers, especially as we're gaining more and more experience, but it's going to happen throughout your entire career, you're always going to have to solve problems in terms of the tools that either you already know or that you're aware that they exist. All right. So, last time we started putting some stuff into our slides here. So, we have this thing, helpful Python functions. Every single programming language will have some function that allows you to return the length of a collection. So whether it's a string, get the length of a string, an array, a list, you know, every programming language will have a variable type for holding collections of stuff. And every programming language will have the ability to get the length of those things. Every programming language indexes those things starting at bucket 0. So anything that has a length of 5, the legal elements are 0 to 4. All right. This is consistent across all programming languages. I suppose you might be able to find some very obscure language out there or something like that that does things differently just for the sake of doing things differently. But generally speaking, any of this stuff we're talking about in here translates to any language. Instead of it being len, where you pass the collection into it, maybe in, like, for instance, in Java, if you have a string named s, you can say s dot length. That'll give you the length of the string. Um, Stuff like that. If you have an array named ar in Java, it's ar dot length. So a little bit different twist on the same thing, but ultimately they're giving you the same information about that collection so that you can work with that collection. All right, we're going to run into some other things today, dealing with like concatenation and stuff like that, which also translates into other languages. So one thing I'll probably keep repeating as we go through this is you're not learning Python. You're learning to program. We just happen to be using Python as our example. Um, I guess, and I don't like that. I don't like Python. All right. Remind me, this function right here, ord, what does that guy give me? I know I have it written on the screen, but can you give me context for it? Nothing to do with memory addresses. Unicode value. So we have this chart, and this again is across all programming languages. All modern programming languages use the same chart called Unicode. Older languages used a smaller chart, which is a subset of Unicode called ASCII. So those older ones only had 256 unique things because they were 8 bits. They had 8 bits to represent. So 2 to the 8th power was the number of unique characters that could be represented in an 8-bit character set. Unicode is a 16-bit character set, so it supports 2 to the 16th power of unique characters, which is 65,536 unique characters, indexed from 0 to 65,535. So we have this document that says this number is actually this character. This number is actually this character. So in Python, we have a function called ord that I can pass a character to, like an A, and it will tell me the number that is associated with that character on the Unicode chart. All right. Now, that is something that you will likely not use very often, but it is something that sometimes it's not so obscure that you're never going to run into it. Like we saw last class, I think he gave us the potential solution of saying, hey, we need to move between a number and things that are like A through F, and we need to move that to the number. So he just kind of looked at Unicode and said, you know what? There's a difference of 55 spots between this guy and where we want to be. So let's just subtract 55 from it and we're good. Technically, that worked. It's kind of like a little trick since you knew about Unicode and you could look at the Unicode chart and you can see that an A is this value. And to get to where I need a 10. What do we subtract from the Unicode value for A? Ended up being 55 to get me to a 10. The math just worked. All right. But we decided, even though that will function and that gives you, in fact, it probably actually is a faster solution. So if we're thinking about purely optimized solutions, it's probably the better solution. From an understandable perspective, though, when somebody looks at your code and you're just randomly subtracting 55 from some Unicode value, you might need to think about it for a second to try to figure out what you're doing. Probably not the greatest solution when you're working in like teams of people, because it's unless you put some comments like this is what I'm doing. Okay, so what we did last time is we said, you know what, it would be handy if we had our own little ability, the ability to write our own tools, maybe something that's not built into the language. In fact, sometimes even if it is built into the language and you don't know about it off the top of your head, you might decide, you know what, it's going to be quicker just to write a quick function that does what I want it to do, rather than go and research to see if the thing that I want to do is built into the language. Now, I mean, if it's something complicated, opening network sockets or something like that, you probably don't want to reinvent that. But if it's 10 lines of code that is not overly complex code, it might just be faster for you to write it yourself and have maybe your own little custom spin on it. Let's say you're only working with lowercase values or something like that, when the built-in thing works with across all values or whatever. So we decided, you know what, we're going to go ahead and define something. We're building a tool. This is called a function. So if we put into our, I know I just, oh, I thought I typed over that. Let's give a definition to what functions are. All right, function is a reusable chunk of code that we write once and can call upon over and over again with different inputs. So general syntax for functions, okay, this is regardless of language, is function name, let's call this params / inputs. In fact, let's just call them inputs. Something like that. We have the name of a function. It's going to require some number of inputs, perhaps even 0 inputs, but some things to make it work. Inside, you have logic that takes whatever was handed to that function and does the magic, whatever that thing was supposed to do. And then if it made sense, it would return some answer. So in our case here, what did we do? We wrote a function. We named it char2digit. We called it that because that's what we're doing. We are passing in a char, like an A, and we want to have it spit out the number 10, for example. All right. So, and we did that by using this map thing. So this is just a word. We could have called this LOL. You know, this is the name of a variable. Good.
The logic.
Yeah, the logic is just all this stuff. Do what you're going to do, whatever your code is for that particular problem you're trying to solve. So what we decided is, you know what, if I had a collection of all the possible values that we might have here, if I wrote 0 through 9 and A through Z, for hex, we only need A through F, but now this works for the entire alphabet, so it'll work for any base until we run out of letters in the alphabet. We see that a 0 is at location 0, a 1 is at location 1, and A is at location 10. So we have this very specific order of characters that we put in this string that if I were to take a character like A and I were to search through that string looking for A and then return the location where I found it, I would get my 10. All right, so we figured out that, oh, we can do this. Now, I named my variable map here. Nothing keeps us from calling it LOL or something. This is just the variable name. We typically want to have variable names be somewhat meaningful. In this case, we are mapping between a character and a number, hence calling it map, but it's not, that's not like a built-in term. Although in some languages, map is actually built in for something else. So be on the lookout for when you happen to name your variable something that in that particular language happens to be built in, and then just change your variable name if it screams at you. Go ahead.
Is it red?
My color coding in online GDB. I mean, I agree with you. It looks like length is treated as a function. So perhaps map is actually the name of the function, but since I didn't put parentheses around it, maybe it is built into Python. But since I'm not using parentheses, it's able to tell the difference. But yeah, I can't. This is online GDB's color coding thing. But it's a reasonable question. Why is it red? Go ahead. Oh, okay. So let's just walk through this again to remind ourselves what's going on here, and then I'll talk about the -1. The -1 thing is kind of a bailout, and it's actually not necessary in Python, but I think it's good programming practice, and I'll review that. So let's just walk through the logic, and then hopefully I don't forget to answer it. If I do, yell at me. All right. So we're going to pass in, when we call char to digit, right here, when we're defining this function, this is us creating an ability, not calling it. All right. If my entire program is what I have highlighted right there, my program would output nothing because I'm never actually calling upon that function. This is me bringing it into existence. I've run to Home Depot, I've bought it, I've checked out, I'm bringing it home, but it's still in the box. I haven't actually used it to solve any problems yet. All right. And we see though that down here, when I was getting my current bit, I called upon my char to digit function, passing it whatever the current character we're looking at from our initial value. And we'll walk through this again. But let's just focus on char to digit up here. So char to digit is going to take in some character as a parameter. The possible options for this, we know, because we're building this tool. We're not doing any error checking here to make sure that whoever's using this tool hands us good stuff. But we're making the assumption, since we wrote the tool and we are the ones that are going to use this tool, that we're going to send it stuff that it makes sense. Okay? So the possible inputs to this function will be 0 through 9, A through Z. All right? Those are the possible inputs. If I pass it a question mark, Python is not going to scream at me as I gave it a bad input. It's going to return a -1. I did not find a question mark anywhere. Question is why -1? We'll talk about that. All right, so I pass in some character. Let's say I pass in an A. All right, so coming in here in our little example here, HR would turn into an A. All right. So just kind of keep that in the back of your head. That's the example we are walking through here. All right. So now I've defined a variable here called map, filled it up with 0 through 9, A through Z, just because that's our little trick we figured out. I've defined another variable, pause. I'm starting it off at 0. My intention here is I want to go through this collection of characters starting at position 0 all the way up to its length -1. And I want to check each of those to see, does this match the guy I'm looking for? All right. So pause will start off at 0. These are both examples of us remembering something. We're creating variables to remember something. Now we're going to create a loop. We're going to keep doing something. Loops say repeat the stuff that's inside here over and over and over again as long as this Boolean expression remains true. So let's talk about Boolean expressions here. All right. Boolean expression is any expression that boils down to a single value of true or false. And I'm going to put that in all caps, any. We're going to see many, many, many examples of Boolean expressions as we go through the course, and you're going to use Boolean expressions all the time. They're the core component that all of our if statements are around. It's how we ask a question is a Boolean expression. And it's also the core component that all of our loops work with. How long do we keep going? As long as this dude's still true. So a Boolean expression is any expression, regardless of how simple it looks or how complex it looks at a glance, that boils down to a single value of true or false. And the reason I'm emphasizing this is we're going to very quickly be getting into doing things with like ands and ors, where something needs to be this and it also has to be this. A Boolean expression that contains those is going to look more complex than a simple Boolean expression, even though ultimately it boils down to one value of true or false. Okay, so for example, although I guess the weather has changed, but if I say it's cold outside today, true or false? I think it's supposed to be pretty nice today, isn't it? 72 considered cold? Probably not cold, so that's false. What if I say it's warm outside today? I can say that's true. What if I say it's warm and it's snowing? False. It's not snowing. It is warm. So true and false boils down to false. For an and to be true, everything needs to be true around it. If I said it's warm or it's snowing, that would be true. If any of our selections are true, the whole thing becomes true. Okay. We're going to have plenty of practice with this, but the punchline is we need to get used to when we see code, don't immediately react. Take a moment and try to resolve what you're looking at down to what it actually will equal. A lot of times Boolean expressions can look scary, even though when all is said and done, when the smoke clears, it's a single value of true or false. All right. So that's what a Boolean expression is. We've already been using them with if statements and loops. All right. So this guy right here is a Boolean expression. Pause is a number. Currently, it started off at 0. So I'm asking, while pause is less than the length of map. Okay, length of map, I think, should be 36. So is 0 less than 36? Yeah, that's a true statement. So this entire thing right here boils down to true. It's a Boolean expression. And while loops, any loop, keeps going as long as the Boolean expression that is contained is true. Go ahead.
What's the name for the two variables being compared, like by the less than something? Because I know there's like operators and operands. when we're talking about like numbers and stuff, but
Well, I mean, I suppose these would be the operands, and this is the operator. I wouldn't worry too much about that at this point. Um, I mean, that's not coding stuff. That's the same thing from like math classes or something. You know, if you have the plus sign, 3 plus 7, the 3 and the 7 are the operands. The operator is the plus sign. Yeah.
Could be thinking about this wrong, but what would be an example of like not a Boolean expression? Isn't everything like even binary? Isn't that functionally true and false?
Is that a Boolean expression? Sorry. Right there.
Well,
What does 6 boil down to? Does 6 boil down to a single value of true or false? Not a Boolean expression.
okay.
You want to make it look a little more complex? 6 divided by 2, is that a Boolean expression? It's an expression, but that guy boils down to a 3. Is 3 one of true or false?
Gotcha. Okay.
Yeah, so
Okay.
it's got to be that specific true or false.
Gotcha.
All right, and we use it to ask questions, either once with an if statement or over and over and over again with loops. All right, so this is reinforcing this idea of how do humans solve problems. Memory, asking questions, repetition. Variables, conditionals, if statements, and loops and functions. All right, so as long as pause is less than the length of map. Now, if you were to translate that one line there, what am I actually accomplishing there? What question am I really asking? Anybody have an idea? If you were to turn this into English and say, why have I put all this stuff inside this while loop? How long is this while loop going to keep going? Go ahead. Yep. So we chose to start pause off at 0. So that's the very first time we come in here, pause will be 0. I want this loop to keep spinning as long as pause remains less than 36, is what the length of map is in this particular case. That means that, and we see here that each time through, pause is becoming 1 bigger. So it started off at 0, then 1, then 2, then 3, then 4, then 34, then 35. Finally, when pause is 36, is 36 less than 36? It's not. So we'll fall past the end of the loop. So what are we really asking here? We're saying, as long as pause is still a legal position in my string, let's do some stuff. Go ahead.
Sorry, it's a little off topic, but in Python syntax, is it required for while and if loops to have the conditions in parentheses, or can it be outside?
That's a good question. You want to know, do I need to do that?
Yeah.
I think you could probably do that in Python.
Okay.
We can find out real quick. Yeah. I would encourage you to always put it in parentheses.
Is it only with while and if loops, or can a for loop do that?
All of them. Yeah, the answer I just gave there is a generic answer for across all programming languages. I would say use parentheses when it makes sense. You know, don't just put parentheses to put parentheses, but I think clearly, let's just duplicate this line. Because now it comes down to which is easier to read versus what is technically legal. Now, it's not like this guy is difficult to read. So it's not that big of a problem. But if I'm looking at this, I probably prefer to see all the stuff associated with this while loop being contained inside of these parentheses. Feels like it's kind of a package. Here's all the stuff that's part of the while loop. Even though in Python, it's technically not required. But C, it is required. C++, it is required. Java, C#, Swift, all required. If you start seeing patterns across multiple programming languages, learn how to do it the generic way that will always work as often as possible. Then you don't have to bounce back and forth between the languages. All right. But if you wrote it the other way, I'm not taking points off. If it works, it works. It's fine. Just make sure it makes sense to you. All right, so this while loop says keep doing something as long as pause represents a position somewhere on my string. And what am I going to do each time? I'm going to ask a question. I'm going to say if map at position pause. So this syntax right here says give me the value within map that lives at the particular pause that pause currently equals. So the first time through here, pause is 0. So the character at position 0 in map is right there. And if you want to, it's not going to, because I have my 10 through whatever's is going to look bad. So I was going to show you this, but this guy lives at bucket 0, bucket 1, bucket 2, bucket 3, 4, 5, 6, 7, 8. Bucket 10 is where the A lives. Bucket 11 is where the B lives. So we're seeing a very direct mapping to exactly the thing we need. Hence the reason we chose to do it this way, right? All right, so we're going to ask the question, if the character I currently am looking at, the character that lives at position pause in my collection, if that guy is equivalent, double equal sign, so double equal sign, no spaces between them, equal, equal, returns true if the values on either side of it are the same. Returns false otherwise. All right. Most programming languages will use the double equal sign for equivalence. Why do you think they use double equal sign for equivalence rather than single equal sign? Go ahead. Yep. So we have something called the assignment operator. Single equal sign assigns the value on the right to the variable on the left. So for example, A is equal to 7. A gets the value is how I'll often say it. A gets the value 7. We assign A the value 7. Where in this case, if I say A equal 7, that's a question. That's a Boolean expression. Is whatever value is currently inside of A, is that guy the same value as 7? Now, we don't know what's inside A. How do we know that A here is the name of a variable instead of the letter A? Okay. So one of the things we're covering here, like he just said, is, we have different things that we need to be able to individually represent. We need to be able to say, are two things equivalent versus assign something to it? We need to be able to tell the difference between a character or a string and a variable name. We can't just have these things living out there and be ambiguous. So one of the things that we kind of need to move away from when we deal with programming languages is things are never ambiguous. Whereas in normal life with English or any natural language, we can add ambiguity in there because human beings can kind of fill in the gaps, right? You can kind of figure out in context what somebody means instead of looking at the exact words that they say. Unless we're trying to win an argument and then we look for those specific words to prove them wrong, right? But in general, when we're dealing with natural languages and we're talking to human beings, we don't need to be as precise because people can fill in the blanks. But when we're talking to this computer, our languages need to be very, very, very precise. So understand that this is different than that. If I want to talk about the character A, I would put single quotes around it. Now, Python does not make in the big picture, Python does not distinguish between these two, but there is a difference. What is the difference? Well, let me just explain. In most programming languages, when you surround a character of any kind, that is anything that lives on the Unicode chart, not just letters of the alphabet. Any one of those 65,536 characters that live on the Unicode chart can be represented as a single character by surrounding it with single quotes. That immediately tells us that is not a name, that is not a variable name. That is this guy would be called a char literal, is what that guy is. All right. Every single programming language. That's what that guy is. It's a character, and it's literally a character. So for instance, in real life, we have the number 5, right? That's a literal. It's the integer literal 5. We don't get to redefine that. We can't change that 5 now means something different. 5 is 5. Okay. We call those things that are hard coded, not changeable, we call those literals. All right. Not all that important. I mean, I'm not going to test you and say, what do we call this thing? But just when you see somebody write something or mention something, and they say, this is such and such literal, what they're really talking about is this is a hard-coded value that just exists. It's not a variable that you're changing or setting or something like that. All right. So this guy would be a char literal. This guy would be a string literal. All right. And when we get into strings a little bit more, I'll talk more about how strings actually work, because strings are actually an evolution of something called a character array, which I think he mentioned last class. But it's a collection of characters. But the idea was way, way, way back when, it might have made sense for us to have a collection of characters. But typically, as human beings, if we're trying to work with a collection of characters, we probably have words that are in there, right? It's probably a sentence or a collection of characters that equal the word elephant, something like that. All right. So what we really mean is a string. We really mean something that has semantic meaning that we're going to use for solving problems, not just a generic list of chars. But we might have a list of numbers that we want to do something with, sort it, putting in a certain order, finding the largest value, finding the smallest value, whatever it is. But all this stuff kind of started in C as a collection of primitive types. You could have an array of chars, an array of ints, an array of bytes, an array of longs, an array of shorts, all those things. You can have a collection of anything you can create a variable of. But strings are kind of special. We are going to use strings more often because that's how human beings communicate. So it makes sense in all programming languages for them to have this kind of this evolves type called a string, which is everything that the collection of chars used to be, but then it has some built-in features that kind of make using it as a string for kind of what human beings might use it for a little more convenient. Go ahead.
The string array basically like, array or, and then given to.
Would you say is a string array?
Yeah.
A string array would be a collection of individual strings. Like the
the
first one could be
letters.
hello, the second one could be elephant, the third one could be cat.
Oh, I thought you meant the individual letters.
A char array would be that.
Oh,
A char array would be bucket 0 might be a question mark. Bucket 1 might be the letter A. Bucket 2 might be the char 4. Single quote 4, single quote, which is different than the number 4. We saw those on the Unicode chart. All right. So in any case, punchline here, and these are all just kind of things you'll get used to over time. I'm just kind of throwing it out there. But the double equal sign is for testing whether the thing on the left and the thing on the right are equivalent. Now, some languages don't let you test everything using the double equal sign. And we'll talk about that when we get into memory addresses a little bit more. But for right now, since we're pretty much thinking about primitives, integers, chars, the double equal sign can always compare those. where we start getting a little sketch is like the double equal sign when comparing two strings. Like, is the string hello equal to the string hello? That kind of depends on the language. We'll talk about that when we start getting more into strings. Okay. So in order to have two different abilities, testing equivalence and assigning a value to a variable, we need to pick two different operators for accomplishing that. So most modern programming languages say double equal sign is how we test if two things are equivalent. Single equal sign is how we assign a value. It's a choice, okay? Because it's a computer, it's not going to fill in gaps for us. All right. So we're asking the question. This guy right here, this is the current character that we are looking at inside of this string called map. So the very first time, we're looking at the character 0. The 10th time through, we're looking at the character A. Because each time through, pause is becoming one larger than it used to be. It's going from 0 to 1 to 2. So each time through this loop, we're just asking, what is the current character that we're looking at for map? And does it match the guy that whoever called me this time, does it match the thing that they're looking for? So if I pass in an A for HR here, if I pass in an A, we're going to go through this loop 10 times before we finally get to pause is equal to 10. So then map at position pause, map at position 10 will boil down to an A. And then we'll say, oh, that is the character we're looking for. Because I passed it an A. That's what I wanted to find. If it is the character we're looking for, what are we going to do? We're returning the position we found it. And A was found at position 10. So we're returning that 10, which is exactly what we want. We want to give it an A, and we want it to give us back a 10. Make some sense? All right. Now, this is going to happen over and over and over and over and over again. But two things can occur. Because we're the one who wrote this tool, we know that we're only passing at things that are 0 through 9 or A through F. We know that's how we're going to use it. All right. But all of us have had devices, objects, or whatever at home that we've put things into that weren't intended to be put in there. I remember my brother and I, when we were kids, we had a VCR. Everybody know what those are? We actually had a Beta 1 and a VHS 1. We loved putting pieces of toast in there because we were stupid idiots. But we did. That thing was not meant to put toast. Oh, my dad was so mad because they don't work that well when you got crumbs and stuff in there. We would actually toast it first. That way it would really flake off. Yeah, he was not happy. So, the makers of the VCR didn't put protection stuff on there. They didn't gate it, where only the adults could unlock it to put anything in. So that was a free-for-all. That's the way my brother and I looked at it. All right, but since we know we're the ones who are going to use this, we can call it with just the stuff that we care about. But what if somebody else who wasn't aware what our function's supposed to do passed it a question mark? Just cuz. We know we're using this as a tool for converting between different bases. So we need to do this little mapping between 0 through 9 and A through Z to get the numbers associated with it. And all of a sudden we get a question mark in there. And we're like, that doesn't exist in our world of mapping. Question marks aren't part of how we represent different bases. We would have to make a special case. Out of curiosity, this is more just like a trivia type thing. When might we decide that a question mark could be part of converting things between bases? Is there a scenario that you could give me where potentially you would write a number that is like
If in a base part
yeah, something like that? BAD question mark 12C? if we happen to be needing bases larger than base 36, all of a sudden we have to start getting creative and saying, all right, I need to assign new symbols for what is a 36 and 37 and 38 and a 39. It's plausible we decide to go ahead and start with punctuation, right? Just hit all the punctuation stuff afterwards. The geeky thing to do would be switch to Klingon, which is a documented language, by the way. You know, you've seen it in shows and they joke about it, but somebody has made a Klingon language and it is pronounceable. Yeah, so in Big Bang Theory, when you see them communicating in Klingon, it's based on reality. That was brought out of unreality by geeks. I think that's correct. But so in any case, it is plausible that you could be representing huge bases using things outside of the alphabet, but not in reality. We're not even close to the point where we need bases bigger than base 16. And we have plenty of room to grow there. So this is probably not something that could happen, but it is plausible. All right. So given that, even though we know that we're only going to pass this things that should exist, if we did pass it a question mark, we know that we are never going to find a question mark anywhere inside of this function here called, or inside this string called map. It's not in there. So we're going to go through this loop 36 times, all the way through the alphabet, right? And we're never going to find our answer. We're never going to get inside this if statement. So we're never going to return pause. Remind me, what does return do? Most importantly, it exits the function. It potentially could return a value. You don't have to put a value after return. Correct. 100%. Yeah, that's something we're going to actually harp on. Print displays something to the screen. Return sends something out as a response. So the difference would be if I told you, if I said, what is 2 plus 4? You have two options. You could blurt it out to me and say that's 6. That would be returning the answer to me. Or you could write it down on the piece of paper in front of you where I don't necessarily see it. I was going to use that value to do something else. You know, a lot of times we need like a real-time value, you know, add these two numbers together, I'm going to do something with it. So displaying something to the screen isn't more or less important than returning something. It's just a different ninja move. Sometimes you want to display stuff to the user. Sometimes we're giving an answer to a question so that the user potentially uses that for another part of the program. All right, so return makes a function immediately end and then potentially can return a value. In this situation, we have chosen to also return a value. The value of pause is the location within map where we found the thing we were looking for. That's what this logic expresses. Go ahead. That'll actually happen for us. So I'm getting there. Go ahead. No, that would make no sense. Yeah. Some languages, if you said return print pause, would display a function called print, would give you like a weird memory address you're using thing, but it doesn't make sense to say return print pause because print is like a directive that says do something. And what does it do? It talks to the operating system and ultimately spits something out on the screen. There isn't an answer from that. There's a result that occurred from that. All right, so in any case, we know with a question mark, we are never going to get to this line, which means this function will never end early. It will never end because we found our answer. We'll end up going through, checking every single spot, never finding a question mark, falling past this while loop. This while loop ends naturally when pause is equivalent to the length of map. That's when the while loop dies a natural death. All right. And in this case, when it dies a natural death, we do not spin back up. We instead drop past the loop and move on to the next line. You can have hundreds of lines down there if you want, but the loop is now gone. It's dead. We've done the damage we can do with it. Not all loops have return statements in it, but this particular one was saying, hey, I'm going to start looking through this collection. And as soon as I find it, I'm going to bail out of this function because my task is done. But if we go through that thing over and over and over again and we never find our result, we're going to fall out of this while loop naturally because we've checked everywhere. Yet I'm still alive. And what am I choosing to do? I'm choosing to return -1. Now, if I didn't do this, if I didn't return that, I can still run this. It still works just fine. Here's the difference. If I did, let me actually force this. I'll just come down here. I'm going to make another call to this function. So I'm going to say print char 2-digit of a question mark. All right. So I'm going to go ahead and just randomly call my function char 2-digit. I'm going to pass it a question mark, which we know it's not going to find. If I don't return a value like -1, it's going to give me none. What are you doing? All right. It gives me none. So let's just create a slide for this. Nothingness. That's probably hyphenated, might be hyphenated. Let's assume it's hyphenated. In Python, none means nothingness. The absence of a value. Same thing as null. In C, C++, Java, C#, the equivalent to this is null. I think C# actually is a capital null. C++ is a capital null, but let's keep it at relative high level here so I don't have a couple of bullet points. Anybody know the third one that is less common but exists? It's nil. It's another one you'll see in existence in some languages. Not super common, but those three things all mean the same thing. They mean nothingness. All right. And typically, nothingness isn't necessarily a bad thing, but it's an important thing. Because if you have something that's nothingness, you do not want to do stuff with it. Right? So for instance, if you have, once we get into object-orientedness, and we start having functions that return instances of objects, more complicated things. I think we talked about the object-oriented telephone, pile of wires thingy, whatever. So as we get into coding more, we're going to be inventing our own variable types that are more complicated than just an int or just a char. It might be a variable type that contains both an int and a char. Maybe we're holding on to maybe it's an int and a string. So maybe it's their name and their jersey number for a player, something like that. Okay. Well, but let's say you have a function that says, give me the player from the roster that has this jersey number. And let's say that we never find a player with that jersey number. That function is going to return none. Now, that's fine. Not a problem yet. But if I don't deal with that, if I don't say, okay, I've gotten my answer from my function. Now I'm going to ask that guy, what is your name? I'm talking to nothingness. That's going to start causing errors. When you're asking nothing to start giving you results, your expectations should be super low. Because you don't know what you... A lot of times ask yourself, what do you expect to get out of asking nothingness? The equivalent of talking to a wall. If I walk up to this wall and I ask it to add 2 + 4 for me, I'm going to be waiting a while for my answer, right? Programming languages are going to bail on you and say, look, you cannot ask nothing for something. All right? So one thing, the reason I did this as a -1, full circle. There is a precedent for this. I want to say maybe in Python it's find is the function, but let me just use the function called index of from Java. So index of in Java. Every language has an equivalent. I guess it's possible that there might be some languages that don't actually have an equivalent, but basically every language has an equivalent to this. This function, let me give it to you this way.
Oh,
I'm going to say string s is equal to hello. We'll just do this as an example in Java. So then I would say s dot index of e. That guy would give me the location in that string where E was first found, which is location 1. E is found at bucket 1 in that string. S dot, well, what do you mean for the, an integer doesn't have the ability to call index of.
okay.
Yeah, integers are primitive types, strings are object types. That'll become more obvious as we practice with these things more, but just assume it's for strings only right now. That's what it does. That's what this tool does. Somebody in now, first of all, haven't we effectively written our own index of? Isn't that what char to what do I call it? Char to digit or whatever does? I give it a char, and it tells me where in this magical string that's in there called map, where that guy was first found. That's what it does. We wrote index of. It's not like it's a super special thing. All right, so if I say index of L, this is 0, 1, 2, it's going to return a 2, the first location where L was. Now, what if I say question mark? Does hello have question mark anywhere in it? No. This guy will return a -1. Most programming languages have something like this, where it's still, it returns a number for everything. And that number is always positive when it worked. It can return a -1 if it didn't find it, and then you can just say, if the answer was greater than -1 or greater than equal to 0, that means I have something usable. Go ahead.
So like if this equals stage R, then return the index of or find of stage R.
Okay, so what he's asking is, can we get away without using pause? That's, I think, what you're asking, right? So what if we got rid of pause here? That guy doesn't exist. What have we lost? We no longer can ask, are we done looking at places in the string? And we're not done yet. I mean, it's a good question because, I mean, first of all, if it makes sense the way you're doing it, don't just try to change it just because you don't need an extra thing. Sometimes we'll create a variable just because it's cleaner. If variables, by definition, we typically say, put something in a variable if you need to use it more than once. But what if you're only going to use it once? You might still say, I'm going to go ahead and put it in a variable so I kind of have it labeled as like a self-documenting code that just kind of tells me that this is what this value is. I'm only going to use it one time, but I've kind of labeled it. And then you can go do something with it, but I'll come to you in a second. So if we didn't have pause, we wouldn't be able to ask this question. If we didn't have pause, we wouldn't be able to say, is this particular place in that collection the thing I'm interested in? So we would never be able to ask these questions. What he was asking is, well, okay, well, let's just make the assumption we could ask those questions. In the end, once I knew I found the thing, couldn't I just return the position? Now, having said that, if we were writing this in Java, let me just write this again real quick in Java. well, I'll pretend like this is in Java. That's the Java equivalent of this, which I think is kind of where you were going. Is like, oh, can't we just use a built-in thing? Probably, yeah. I mean, like I said, I'm pretty sure in Python it's fine. It's not all that important for this exact moment. All right, let's just look it up since we're Python equivalent Java index of string dot find. Yeah, it looks like it's called index. So in Python, I'm just making a guess at the, oh, I can read it up here. The middle part of my screen does not display here, by the way, just so that's why I keep looking over here. Oh yeah, here's the find method. Without going too deep into this, if we were doing this in Python, I'm guessing there might be multiple ways of accomplishing the same thing that would not be uncommon in programming languages. So in Python, we might say map dot find or map dot index. Either one of those might be a thing. And now what we've effectively done is we've written our own function called charge a digit that acts as a wrapper for us defining the exact string that we're working with here, and then just returning whatever map.index gives us for that string. Not necessary. We could have just worked with this string dot index. Like that. These two lines mean the same thing. Map right here is a variable. Variables, when you go to use them, they resolve to the value that's contained within them, which means that when we have map right here, it's the same thing as if we wrote the whole string out. But why didn't we write the whole string out? We put it in a variable in case we need to use it more than once. In this case, we're not using it more than once, so we could just hard code the string in there. It's not like an alternative. These literally mean the same thing. When our code is running, map will become its contents. All right. And this guy right here returns the position where it's first found or -1 if it wasn't found. So this is kind of a convention in most programming languages. When you're searching for something, a -1 would be the convention by which it operates. You had a question still, right? Yeah, I wouldn't in general recommend it. That's not even a fair statement. This is fine. It just for us, it took away the practice of working with loops and stuff like that. But yeah, you certainly could.
Function on the back end, essentially doing what we just did, like, is the back end of this function?
Yeah, it does the same thing.
Like, they make like that function.
100, yeah. Index of, or it looks like index or find here in Python, exists to say, if you provide a string and something you want to find in there, I will tell you where it first occurs or a -1 if I didn't find it. Almost every programming language has a tool like that built in. Almost, it'll very likely be almost identical to our code. Maybe they did a little and named their variables different or something like that, or do a little more error checking or something, but generally speaking, it'll be identical. It's not like some kind of magical, more complex version. It's the same junk. It's just packaged up for us. Go ahead.
So like in Java, there's like the import, like math dot whatever. Can't you do the same for pretty much?
Python, yeah. So Python has a zillion libraries too. In fact, that's actually the reason Python's become so popular is because there's a zillion times 4 libraries in
You
Python.
can do that instead of having like map, right? For that.
Well, I mean, if it exists, I mean, the libraries don't just exist for everything. I mean, somebody, when we say a library, you might take your program and you say, oh, I'm going to import a library to do something. Maybe it's some of this AI stuff that exists today. If I want to do something where I can visualize data, you can import something into Python that already does that. Like one of the things is called NumPy, is a popular tool for data science stuff. So somebody has said, you know what? I bet you data scientists need to do a lot of stuff with data, and they might want to visualize that data. So we're going to provide a library that has a whole bunch of stuff for working with data and visualizing it for you, so you don't have to reinvent the wheel. Then you would import that library, make sure you understand what tools are in there. It's kind of like when you go out to Home Depot or whatever, and you buy one of those the toolkits that come with every tool under the sun. You don't know what half of them are for, but you know, I got it, right? Then you lose them over time and you end up with just the drawer of stuff, right? But it's kind of like that type of thing where you are given this library of a whole bunch of capabilities, and then you can pick and choose out of that what you actually want to do with those. And we kind of mentioned this earlier, where sometimes this is a, you know, a real thing. But sometimes it's just easier for us to write something quick ourselves rather than go and hunt to see if there's some library out there that already does it for us, especially with something like this, where, you know, this is a pretty easy function to just write. For most of you, you might feel right now you couldn't just sit down and write this. That will come through practice and stuff. But I hope everybody in here at this point, when I walk through this line by line, it makes sense to you. Okay, there's going to be one day it's just going to click, and things you used to think were really difficult, you're like, oh, that's all that is? Because right now your mind is at war because you're so used to solving problems with human beings. It's hard for you to just change your mindset to talk to this guy. So it's just kind of a thing. So if that's where you are right now, is when I walk through this, it makes sense, but you don't think you could write it yourself, you're right where you need to be. If when I walk through this, it's complete gibberish to you still, I would maybe question why it's complete gibberish. If you've just been checked out, not doing anything, if you've not been going through the homework stuff, it's not your cup of tea, whatever it is. Kind of like me with sheet music. Like, I played in high school, I played trombone. Cannot read music. I was third chair trombone. I just copied what second chair did. Figured that was fine. Nobody said anything to me. I would even turn the pages like that. What am I looking at? All right.
Not broke, don't fix it.
That's it. We have much more talented musicians than I out there. Well, except when it comes to singing Backstreet Boys and karaoke, I'm pretty solid. All right. So we would probably call this a wrapper function. Sometimes we just wrap something and it kind of makes sense. But for us, I would pretend like something I have highlighted there doesn't really exist quite yet because we want to practice writing these primitive type things. Go ahead.
You could like, for the initial value, do you think you could like put some like legal character in there, just to be like what will do with the character and initial value?
Oh, I got you. Like this guy. So if I put a question mark in there, do you want me to leave this the way it is right now, or do you want me to put the back to the return -1? Or we can do both. Let's just do both. All right. So here, let me get rid of this thing down here. So we're only dealing with our code. All right. So just to set the stage, we have now taken our charted digit and we took out that return -1 from the end. Where if we didn't find it, we just let it die and it returns nothingness. All right. Keep in mind that that means where are we using char to digit? We're using it right here. So we're saying whatever current character I'm looking at, I want to pass it into char to digit. That guy is going to give me my answer. What am I going to do with that answer? I'm going to add it to my running total. All right. So in this particular example, as soon as we get to that question mark, we're going to pass a question mark in here. This guy's not going to find it. He's going to boil down to none. I'm storing none inside of cur_bit. That's okay. So far, we can create a bucket that has nothing in it. That exists. You can go to Walmart, Target, whatever, walk out with a container that has nothing in it, right? So we're okay so far. Nothing's crashed yet. But right here, I'm saying answer, I want you to now become, we're assigning a new value to answer with the single equal sign. Answer, we want you to add to your current self, whatever place is, times whatever cur bit currently is. Now, what do you expect to get when you multiply some number times nothing? It doesn't make a lot of sense, right? So this is kind of a free-for-all. We're gonna get an error from this. So it says operand type for star for times, not defined for multiplying an int and nothing. Yeah, the none type. That's nothing. All right. So that's what happens if we use none in this case. But there's a rationale to it. It's not like it's just, oh, that's just how it works. It doesn't make sense to multiply nothing by anything. Just it's not a thing. But if we go back in and we update our code up here to return -1, and just to reiterate something we talked about before, notice that this return -1 is not indented under the while, which means it's not part of the while loop. It comes after the while loop has completed. All right. All these things that are indented under that while loop, they belong to the while loop and are processed through the iterations through that loop. All right, so return -1, this line only will ever get executed if we never got to this line, which in this case would be a true statement. So now with that question mark, we're going to get, instead of none right here, we're going to get -1. Can we store -1 inside of our cur bit? Yep. If nothing fit in there, -1 probably will. All right. Then we're going to come down here. We're going to say answer. We're going to assign a new value to you. What's that value? It's going to be whatever your current value is, plus whatever the place currently is. Remember, it's the ones, depending on what base we're working with, the ones, the 16s place, the 256 place, times whatever's in cur bit. Cur bit currently has a -1 in it. This was for the question mark, right? What is -1 times whatever place is? Some negative number, negative place, right? So we're going to get an answer out of this. It's just not going to be the right answer. Because now for that one iteration through there, we've now messed up our sum by adding a negative number. So an answer, but not the answer.
And we got that by putting a character that wasn't in our thing, or what did we do to change it to make?
This guy right here. We just threw a question mark into the number we're trying to.
So it read it, but we made it so that it returns -1, so then.
Yeah, it didn't find it inside a map. It didn't find that character anywhere between 0 and 9 and A through Z.
So how can you prevent it from like getting -1 and then multiplying by the sum and the answer to then just, giving you an error sign or something, or just stopping the code altogether?
Well, you can ask a question. So I can come here after I get cur bit and I can say if cur bit is equivalent to -1, print bad value or something like that. And then I can just say return. Oh, actually, we're not in the function anymore. So the return thing, well, if we were in a function, that would still work. Okay. But we'll just say bad value. We'll still get the answer at the end, but we'll at least see that, oh, I got a -1 out of that guy. Something wasn't right. So we just asked a question about cur bit. Once we got cur bit from char to digit, we just double checked it. We said, look, if you are -1, that means I didn't find you. I kind of want to let my user know that they cannot trust the answer I'm about to give them. Go ahead. Oh, certainly. Yeah. We'll keep adding to this. But yeah, we can certainly make it more complicated than this. So this would kind of be error checking type thing. Now, if you're writing a professional piece of software, working in a big team, whatever, having error checking and stuff probably makes pretty good sense. But for us, we're building a tool that only we intend to use. We can just say, I'm going to use this as intended. Let's keep it simple. Let's not put a whole bunch of error checking into something that I know I'm the only one using. That's a reasonable thing to do, you know. But if I'm going to put this in someone else's hands, we probably want to put guardrails up. It's like training wheels on a bike. All right, make some sense? All right, questions, comments, concerns, bribes. All right, I'll see everybody on, what is it, today, Thursday? I'll see everybody on Tuesday. I don't remember what the assignment is this weekend, but there's something up. And I think everybody now has everybody but one person, but I don't know if I haven't seen that person in class. So has had their Google thing made, so I have access to it.